Hello and welcome. So today we'll go through the topic of communications. So this is a very practical and very interesting topic that is often overlooked. So today we'll go through 6 of the latest questions with some practical, real life and exam friendly explanations to help with your preparations. So let's jump into the first question, and this one will be taken in some way from the radio navigation. However, you also need to know all the radio wave propagation and their frequencies for communications. So which phenomena will normally influence the reception of VHF transmission? So remember that generally speaking, the VHF transmissions are line of sight, meaning they will be influenced mainly by antenna position, by the terrain, by the elevation. So if the transmitter and receiver are positioned higher, then the range will increase. And of course, vice versa, if you're flying through mountainous terrains, these transmissions will also be interrupted. And so for questions like this, the level of aircraft and terrain elevations will most likely be the correct answer, as well as the terrain is always a factor when it comes to VHF radio waves propagation. And here, however, I wanted to just mention one interesting thing, because VHF is used for normal transmissions. We also use HF for long-range transmissions. So, for example, when flying in oceanic regions, so transcontinental flights. And the reason we use it is because HF, of course, has a lower frequency band, and the lower the frequency, the more it is prone for refractions. So the HF can actually bounce out of the ionosphere and increase its range. So it's not necessarily just line of sight. It can be increased to hundreds and hundreds of nautical miles. And this is true that the lower the frequency, the easier it bounces. The higher the frequency, then of course it will penetrate these layers more strong. And here remember that there's also a phenomenon called sporadic E. This is when there are very highly ionized clouds in the E layer of our atmosphere, and these can cause frequencies of even up to 250 megahertz to bounce. And of course, this will include the VHF. And in these very rare events, the VHF transmissions can be heard similarly to HF across hundreds and hundreds of nautical miles. And now for question number 2. So QFE is the RTFQ code to indicate the. So of course we have the 3 key Q codes that we need to know, and the standard pressure setting when it comes to the altimeter settings. So the QFE, when set in our altimeter subscale, it will indicate the pressure at the aerodrome, which means that our altimeter will read 0 altitude. So of course the sole reason of setting the altimeter subscale is always to give it a bias, to give it a point where the 0 starts. So of course, if we use the QNH, which is the mean sea level datum, then of course the pressure at the aerodrome at a certain elevation will be added on top of that reference datum. If the reference datum is the same as the aerodrome elevation or where we are, then the altimeter subscale will read 0. Of course, the standard pressure setting is 1013.25 hectopascals, as it is in EASA. This will give us the flight levels. And then lastly, there is a Q code called QNE, and the QNE is not an altimeter subscale, it is an altitude. So when you have the standard pressure in your altimeter, then the QNE will be the altitude corresponding to that standard pressure setting. And this is mainly used at very high elevation airports. And now for question number 3. So on the readability scale, what does readability 5 mean? So the readability scale, I think, is the most popular question that you can find and see and think of for the communications exam. Most of the people I've spoken to throughout my training have agreed that they all had a question about the readability in their exam. So it's good to remember this scale that only includes 5 different positions. And of course, now the question is how to remember them best. And the scale goes from the highest 5, perfectly readable now and then to uh, readable but with problems, and then the number 1 is completely unreadable. So how to remember it is, of course, always an issue. The way I always say is that remember that the best 3 scales, so 3, 4, and 5, these will be always fully readable. And then 1 and 2, this is when you will be readable now and then, and unreadable. So you will be readable from 3, however with problems, but still readable. 4, you are readable, period. And 5, you are perfectly readable. So the way it goes is usually during the startup of your engine, you may request the radio check in order to make sure that your radio is working well, and the tower or the radio or the station will respond with the readability scale. So I read you 5, or I read you 4, or I read you 1, depending on how well your radio is working. You may also hear in the future a phrase loud and clear. However, this one should be used for in-cockpit, so intra-microphone communication, if you're checking with your instructor partner or the passengers, and not necessarily with the aeronautical stations. And now for the D-ATIS here. So D-ATIS, this is the digital ATIS. ATIS is a report given by an aerodrome. You can listen to it on a broadcast frequency that will give you the ATIS. A D-ATIS is a form of ATIS, the digital one that can be requested via the MCDU. And via the satellites, you can get it into your aircraft written down, but the format is very similar to an ATIS. It gives you information about approaches, departures, special operations, and the weather at the aerodrome. So let's read it together here. So we have the ATIS for the following airport. The ATIS is Foxtrot, and this is published at 2:30 Zulu. According to the METAR from that time, we can expect the ILS approach with segregated parallel operations in use. The arriving runway for arrivals is 02 left, and the departing runway is 02 center. The junction of taxiway Echo Papa and Alpha 3, including the rapid exit taxiway Echo 3 southbound, are closed due to work in progress. The wind is blowing from 10 degrees at 4 knots, gusting 23 knots, and the wind direction is variable from 320 degrees to 40 degrees. Visibility is 10 kilometers or more, or 10 kilometers, period, with few clouds reported in 1,600 feet, temperature 27, dew point 26, QNH is 1012, and no significant weather. And of course, on arrival, acknowledge information Foxtrot. So we need to acknowledge that we received this ATIS with approach on frequency 10.3 and departure with delivery on 1 to 1.65. Departure and delivery means that we'll be speaking with on the same frequency to get our clearance, as well as departure information and guidance in the airport. So now with that in mind, let's see about the possible answers. So runway 02 center is used for departures, and Foxtrot is available for all traffic on 1 to 1.65. No, Foxtrot is available for everyone on the ATIS broadcast frequency or via the D-ATIS, which are not given. The ATIS message is based on METAR from 2:30 Zulu, and taxiways are closed, some of them due to work in progress. This is absolutely correct, so makes sense. Dew point 26, this is correct. Information Foxtrot on 1 to 0.3, again a no, for the same reasons as before. And wind shear warning is in force. There is no wind shear warning given in this ATIS information. And now for the order of priority for the following messages in the Aeronautical mobile service. So the order of priority for the messages when it comes to the RT will always be a very frequently seen question, similarly to the readability scale. And of course, this is something that is worth knowing, just as it is with the readability scale. And there is not a lot, there is only 6 when it comes to the order, and it goes from distress to urgency, including medical pan-pans. Then we have communications for direction finding. So if you're requesting a bearing or some radials, then we have flight safety, then meteorological communication, and lastly we have normal regularity messages, so normal flight messages that are transmitted on the frequencies. And of course the distress, this is the emergency mayday, they always have the highest urgency. And then of course we go to pan-pans, so something that does not require immediate attention but can develop into a distress. Then the direction findings, of course, if an aircraft is lost or doesn't know where it's going, we need to put it, or the ATC needs to put it on the right track. This is why the priority is so high. And then the flight safety messages, so for example avoiding some weather or requesting changes in track or altitude due to developing clouds. Meteorological messages will also include, for example, reports because of the weather or rain or icing and any other like this. And the flight regularity messages, these are the normal communication done on the frequency. And also don't forget that flight safety messages are also messages regarding the altitudes of aircraft, clearances, speeds, and any instructions about the positioning of certain aircraft in flight. So with that in mind, the order here will be, of course, distress. If you see distress in these questions, it's always the highest. Urgency messages, so our pan-pans, and direction finding, number 3, makes the most sense. And now for the last question, so number 6, which of the following only lists instructions and information that should be always read back? So the read back items are specified in ICAO, and there's quite a lot of them. However, generally speaking, always the QNH, because this is in our subscale for altitude. Altitude is always used for terrain clearances, and standard pressure setting is always used for traffic avoidance. So these are very important. QNH is always run back to make sure you got the correct number, so you do not impede on the terrain clearances, especially when flying IFR. However, generally speaking, it is very important. QNH always SSR code. So this is your transponder. This is your aircraft identification. Extremely important. When flying, you always need to read that back. Runway in use as well, so you do not come into approach for the wrong runway. So if the station is giving you a runway, always read it back. And of course, the clearances always need to be read back, either for approach or the initial clearances, or for takeoff, or for your RFR flight, or for startup, any kind of clearance. Then all direction and flight safety instructions, speed, altitudes, headings also are readback items. The runway state information, definitely not. Weather information, definitely not as well. If you were to read the whole ATIS back on the frequency, it would take a lot of time and a lot of energy, and this is not necessary, as you can listen to ATIS messages over and over, and you have the methods as well before. So in this case, it will be the SSR code, so transponder, the QNH, takeoff clearance, and speed instructions will absolutely make the most sense in this case. And this will be everything for today. Thank you so much for tuning in. I wish you all the best with your exams. If you have any questions, as always, feel free to ask below. And I wish you all the best, and I'll see you next time. Bye-bye.